All right, well, let's go through a few of these problems here on this worksheet you would have gotten. One of the review sheets. We'll go through a bunch of these. It won't take too long. Um, so the first ones are all about trig functions, just giving the ratio of these trig functions. So the first couple, I give you all the sides, so it makes it real easy. And the big thing to remember on this, and I highly recommend writing this at the top of your paper, when you're working these problems, SOHCAHTOA, right? Sine, cosine, tangent, and how opposite, adjacent, and hypotenuse sides all relate to each other. Okay, so going in this first one here, all the sides are given, but it's all about the standpoint of what angle are you working from, okay? So I'm working from this angle theta here, and I want to find cosine of that angle. So how are all these sides related? This is usually the first thing I'm going to do is just figure out, even before I worry about cosine, figure out what all the sides are in terms of opposite and adjacent and hypotenuse. Now the long side is always the hypotenuse, okay? And it's always going to be opposite the 90-degree angle. That's the easy one, okay? Um, the one that is straight across from the angle in question is going to be our opposite side. And then that leaves the one right next to or adjacent to the angle to be the adjacent side. Makes sense, right? So in this instance, I'm doing cosine. Cosine is adjacent divided by hypotenuse. So when I figure out what the cosine of theta is, it really is just one number divided by another number. One side, the adjacent side, which is 20, divided by the hypotenuse, which is 25. And of course, we reduce that. So the answer would be 4/5 for this particular one. All right, let's go on to this next one over here. We got sine. So that's opposite over hypotenuse. So from this angle, 3 is opposite. The hypotenuse is 7. So sine of theta is simply 3 over 7. That's it. Pretty simple. Don't even have to worry about this 2 squared to 10 one over here. All right, secant. So secant is just the reciprocal of cosine of theta. So if I can find cosine of theta, all I have to do is flip it, and I get secant. So cosine, as you recall, that's the ka part of SOHCAHTOA. So it's adjacent divided by hypotenuse. So 16 is the adjacent side, 18 is the hypotenuse. So this is 16 over 18, which would be, that's divisible by 2, so that would be 8/9. So if I wanted secant of theta, it's the reciprocal of this, so that's just 9/8. That's how secant and cosine are related to each other. So there's your answer right there. Find cosine, you can find secant. Remember, cosecant is what's related to sine. Of course, cotangent and tangent are reciprocals of each other. Let's take a look at this one here, number 4. On this one, I want to find cosine. This angle here, or this side here from this angle, this is the opposite side. This is the adjacent side. But cosine, I need to find the adjacent side divided by the hypotenuse. I don't have the hypotenuse, so this is the case where you need to figure out what this side over here is. Let's call it C. Okay, so a squared plus b squared equals c squared. That is the Pythagorean theorem. So 5 squared plus 12 squared equals c squared. So that's 25 plus 144 equals c squared, or 169 equals c squared. Square root both sides of this, and you get 13 equals c. 169 is a perfect square. So now we know c equals 13. So when I want to find cosine of theta, the adjacent side I already recognized as 5 divided by the hypotenuse, which is 13. All right, so sometimes you got to find that missing side. All right, let's look at this one, cotangent. So normally, so that's the reciprocal of tangent. Tangent is opposite over adjacent, TOA, right? So that means cotangent is adjacent over opposite. So let's just jump right to that aspect of this one. So I need the adjacent side, that would be 15, divided by the opposite side, but I don't know what that one is. So let's just call this B, all right? And then here's my hypotenuse on this side. Use a little thinner marker here. So I need to use the Pythagorean theorem again, because in order to do this one, I need to figure out what B is. Or you call it whatever variable you want. I'll call it B. So that means our adjacent side, let's say 15 squared plus B squared should equal 17 squared. So this is 225 plus B squared equals 289. If you plug those in your calculator, that'd be all right in this case, but it's good to know those perfect squares. So subtract 225 from both sides. Let's see, that's going to be minus 225 if we do a little math here. That is going to be 64. Oh, that's handy because b equals 8 when you take square root of both sides there. So now we know that this side over here is, let's just get rid of this and write it in as 8. Okay? So now I'm looking at adjacent over our opposite side, which I just found here, which is 8. So when I write my final answer here for cotangent, cotangent of theta, you gotta make sure you have an angle you're taking cotangent of. Cotangent of theta, adjacent side, 15, opposite side, 8. That's your answer. And for context, that means that tangent would have been 8 over 15, just the upside down of that, the reciprocal. Multiplicative inverse, fancy name for it. All right, let's do this last one here of these finding the trig ratios. So this one, I need to find sine. Sine, if we bring in the SOHCAHTOA again, sine opposite over adjacent. So this side over here is my opposite side, sorry, opposite over hypotenuse. And this side over here is the hypotenuse. So I'm missing the opposite side. I got to figure out what that is. You might recognize this as a Pythagorean triple, rather. Pythagorean triples are like whole numbers that if you they will end up being the sides of a right triangle, like 3, 4, 5. But you can do multiples of that, like 6, 8, and 10. In fact, that's what this is here. If we were to use Pythagorean theorem on this, let's say this was not b squared, but b over here, and I did 6 squared plus b squared equals 10 squared to figure out what that is. If we did that work, we would actually find that b equals 8 if we did that. Okay, so if you recognize that, that's great. You don't have to do this work here, but you can still do the Pythagorean theorem to find it out. So if b equals 8, sine's pretty easy then. So sine of theta, opposite, which we just found is 8, over hypotenuse, which is 10. That makes 4/5 for our final answer there. All right, let's try some of these other problems out. Some of these, we got to find missing sides. So it's still all about SOHCAHTOA. So some of these I'm not going to go all the way through, but I'll get to the point where you set up the equation, okay? And a lot of it is figuring out what sides you're dealing with in relationship to the angle you're talking about. So from this angle here, this is our hypotenuse, this is our adjacent side. So hypotenuse adjacent, that's a cosine situation. So I'm going to say that cosine 48 degrees equals the adjacent side, which is x, divided by the hypotenuse, which is 2. It's a pretty easy equation to solve. All you got to do is multiply both sides by 2 here. So x is just going to be equal to 2 cosine of 48 degrees. So that's all you got to plug into your calculator. Just make sure for 48 degrees, your calculator is in degrees mode. So I'm not going to go, like I said, I'm not going to go through every single little bit of these. Just want to get them set up so you know how to do that most important step there. All right, number 8 here, let's just look at how these things are related here. From 35 degrees, this is our opposite side. This is our adjacent side. The side we don't know is our hypotenuse, but we're only dealing with the opposite and adjacent. So that is a TOA, tangent situation. So tangent of 35 degrees is equal to opposite, which is x, over adjacent, which is 6. So it's very similar to the last problem. Multiply both sides by 6. X is just going to be equal to 6 times tangent of 35 degrees. Pretty easy to plug in your calculator. And when you plug this in, you don't even have to put in the multiplication sign between these two. Your calculator recognizes if you just type in 6 tan 35, you don't have to put the right parenthesis on this one. When you plug it in, it'll still work it out in the right way. Just again, make sure you're in degrees mode. A couple of other ones here, because some of these have a little bit different way of solving. Let's take a look at this one. So 48.2, from this angle, this side over here is opposite. And this side over here, well, it's our, not adjacent, sorry about that. That is our hypotenuse because it is our longest side for starters, and it is opposite the right angle. Angle that's always, or the side opposite the right angle is always our hypotenuse. So I'm dealing with an OH situation. So going back to SOHCAHTOA, that is sine O and H. Okay. So setting this up, sine of 48 45.2 degrees equals opposite, which is x, over hypotenuse, which is 12. And you can see all we got to do is multiply both sides by 12. So x is just equal to 12 times sine of 48.2 degrees. This one here, we got opposite, we got adjacent. This is pretty much the same exact setup as the last one. Sine 61 degrees equals opposite, which is x, over adjacent 7. And the solving aspect of this was similar, multiply both sides by 7. So really x is equal to 7 sine of 61 degrees. It's coming down here to number 11. So on this one, from 71 degrees, this side over here is the hypotenuse. And then the side right next to it here, it's kind of hard because everything's kind of tight here to see that. This is the adjacent side. So I've got adjacent and hypotenuse. That's our part, cosine of 71 degrees equals adjacent, which is 7, over hypotenuse, which is x. So this is a little bit different. So I'll focus on this for a second here. Since x is on the bottom of this fraction here, you can't solve for x with it being on the bottom of the fraction in the denominator. So I need to multiply both sides by x. Okay, so that cancels this out, and I'm just left with x cosine 71 degrees equals 7. But now I got to get rid of this cosine of 71 degrees. So I do that by dividing both sides by cosine of 71 degrees. So I just end up with x equals 7 over cosine of 71 degrees, which, notice if we go back to the original, let me get rid of this part of this, really all that happened here, let me put that back in there, the COS, is that these switch positions, right? Now the x is up to the left and the cosine of 71 degrees is down to the right. So if you see that enough times, you recognize like, oh, I just got to swap those and you can work it out. But then the rest of it is just plug this in your calculator. 7 divided by cosine of 71 degrees. And then this last one here, we've got 40.9 degrees. This side here is our hypotenuse. This side over here is our adjacent side. It's right next to it. So it's a cosine situation of 40.9 degrees. 40.9 degrees, there we go, equals adjacent x over hypotenuse 9. So you can see, multiply both sides by 9. X is just equal to 9 cosine of 40.9 degrees. And you can plug that in your calculator, figure it out. Okay, so those aren't so bad, right? Just got to watch out for this one here when you're dividing by the x. And it's just a little different way of solving that. So these are finding the measures of the angle. So this is the last type of question, the last type of problem you got to worry about here. So find the measure of each angle indicated and round to the nearest tenth. So let's take a look at this here. So you really start these off in the same way you did the original ones, okay? Where we look at this and we have our opposite side over here and our hypotenuse on this side. Opposite hypotenuse, that's sine. But now I just have theta for my angle. So sine of theta equals opposite, which is 12, over hypotenuse, which is 15. But now you bust out your calculator. If you want to actually find this angle and not just the trig ratio, you need to take the inverse sine of both sides. That's sine to the -1. And when that happens, you just get theta equals the inverse sine, or arc sine in some cases, if depending on what books you look at. But arc sine, which is written this way, and inverse sine mean the same exact thing. So these are synonymous here, equivalent to each other. But you just plug that into your calculator. And let me get rid of that here. You just plug this into your calculator and you should get your angle. But you just got to be really careful with this. I'll go ahead and plug this one in, because one of the things you want to do is double check, like, does your answer make sense? So inverse sine 12 divided by 15. One thing you got to make sure too is when you plug this in, put the right parenthesis on your that 12 over 15. If you don't do that, it thinks of it as 12, or sine of just 12, inverse sine of just 12, then divide all that by 15. So in this one you get 53.1 degrees. Make sure you put the degree symbol on there. It is a unit. Now go back to the original thing over here. Let's get rid of this stuff here. Does it look like this is about 53 degrees? Yeah, I'd say it's pretty close. So this is kind of drawn to scale, so it makes sense. So let's go through some rest of these and we'll kind of just set them up, but maybe not go through the whole problem. This one right here. So from this angle, we got our opposite side over here and our hypotenuse over here. And so it looks like a sine situation again. So sine of theta equals opposite, which is 10, divided by 11, the hypotenuse. So theta will be equal to the inverse sine of 10, 11. So just got to plug that in your calculator. And then the last two down here, looks like we have an adjacent side, and then over here the hypotenuse. So it looks like that's going to be adjacent a over h. That's cosine then of theta is equal to the adjacent 12 over the hypotenuse 16. So theta equals cosine inverse of 12/16. And by the way, this is reducible, right? But you get the same result whether it's reduced or not. So you don't have to waste your time reducing that to 3/4, but you would get the same exact answer if you plugged in 3/4 here. Both those are divisible by 4. Okay, so just make sure you're using the inverse. You gotta hit that second button on your TI calculators. Then this last one, it's a pretty common one actually, even though it's our last one. So notice we have an opposite side from that angle and we have an adjacent side. Notice we're not given the hypotenuse here. So that's a TOA situation. So tangent of theta equals opposite 6 over adjacent 13. So that's just the inverse tangent of 6/13, and you'll get your solution with that. All right, that's really about it for this stuff, and I'll post some of the word problem information in a separate video.